To find all 6 trig functions for this ratio, cosine of 2 times alpha equals 3/4. We want to be able to simplify this so we can just say cosine of alpha equals 3/4. So one thing we can do is use a trig identity. We have this one that cosine squared of an angle is equal to 1 plus cosine of 2 times that angle over 2. We have this right here, 2 times alpha. We know that that's 3/4, so let's plug in 3/4 right in there. So instead of saying cosine 2 times alpha, I made the replacement with what our problem says that 2 times alpha is. It's 3/4. So I made that substitution. Now we can simplify. I just add 1 plus 3/4. That's 7/4. And then 7/4 divided by 2, that's the same thing as multiplying by 1/2. So we have this, that cosine squared alpha is 7/8. But if we're trying to find all the other all the other trig functions, we want to find out what just cosine is, not what cosine squared is. So we can use an old trick of taking a square root to cancel out a squared. So when we do that, we have that cosine alpha is square root of 7 over square root of 8. The one thing we should always remember, though, is when we take a square root to cancel out a squared, there's positive or negative answers that are possible here. But because our alpha is between 0 and 90 degrees, we know that this ratio is going to be in this quadrant right here. So we know that cosine needs to be positive. We don't want a negative cosine. So we're going to stick with a positive answer there of square root of 7 over square root of 8. But you probably want to clean that up too. Square root of 8 can be reduced to 2 square roots of 2, because you can factor out square root of 4 times the square root of 2. Square root of 4 is just 2. And then we don't like radicals in the bottom, so we can multiply the top and the bottom by square root of 2. So that gives us a square root of 14 over 2 times 2, which makes 4 on the bottom. Because when you get rid of the radical in the bottom, a square root of 2 times the square root of 2 gives us a 2. So 2 times 2 gives us 4 on the bottom. So this is what our cosine ratio becomes. Cosine of an angle alpha equals square root of 14 over 4. So it took a bit of legwork, but we finally have one of the 6 trig functions. And now you can do probably what you've done on a previous problem. You could label a triangle. And again, this alpha is supposed to be between 0 and 90 degrees, so we know it's a triangle in the first quadrant. And it's a cosine ratio, so the adjacent divided by the hypotenuse should be square root of 14 over 4. So I'm going to label my adjacent square root of 14 and my hypotenuse 4. Now we can use the Pythagorean theorem to find out the missing side. We can say a squared plus b squared, that side that I don't have, equals c squared. So simplifying, just solving for b squared. Then you take a square root, you get square root of 2 for this side length. Now you got a fully labeled triangle. You can go right through and label all the trig ratios that you need. So to label the missing one, sine needs opposite of the reference angle, divide by hypotenuse, square root of 2 over 4. Sorry, these should probably say alpha in here too, because we were talking about cosine in terms of an angle alpha, but still means the same idea. We already have cosine of alpha. We just found that was square root of 14 over 4. And we need tangent of alpha. That's going to be the opposite of the reference angle divided by the adjacent, so square root of 2 over square root of 14. But we don't like radicals in the bottom, so multiply the top and the bottom by square root of 14. But when you multiply the top and the bottom by square root of 14, you get square root of 28 over 14. But square root of 28 can be reduced too, because you can factor out a square root of 4 from it. And so that becomes 2 over square root of 17, square root of 7. But 2 over 14 just simplifies to be this. So that's a simplified version of tangent of x. And then for the other remaining trig functions, you can just flip them. This is 4 over square root of 2. But again, we don't like radicals in the bottom, so multiply the top and the bottom by 1 in the form of square root of 2 over 2. So that can be reduced again too. That's 2 square roots of 2 for cosecant. Secant, again, you just flip cosine. Cosine, we said, is 4 over square root of 14. Secant, is 4 over square root of 14. But I don't like radicals in the bottom, so multiply the top and the bottom by square root of 14. And then the 4 and the 14 can be reduced because both of it divisible by 2. So that's simplest form of secant. Then you gotta do the same thing with cotangent of x. Flip what you got for tangent of x. So it's 7 over square root of 7. But then multiply the top and the bottom by square root of 7 because we don't like radicals in the bottom. Oops, this is going to be a positive 7. The 7's cross cancel, so you just got square root of 7 for this guy. Ooh, a little messy, but there's cosecant x, there's secant x, there's cotangent x, and then we've got the other three. Cosine is what we found. And again, these shouldn't be x, these should be in terms of alpha, but there's your cosine of alpha right there.